Hello. You think I can speak without the mic, or you prefer? Can you hear? With the mic. Okay. So, is it better? Is it enough? Yeah. So, welcome. First of all, my name is Niccolò Angioni. First of all, I'm a trumpet player. I studied at the Royal Conservatory. It's not working. Maybe can you turn it a bit up? Hello? Is it better? Yes. Luckily we have a sound guy in the house. Wow, so loud. So I was saying that I'm first of all a trumpet player, and I studied at the Royal Conservatory in The Hague. I did my bachelor in jazz trumpet, and then I moved on with jazz composition. And exactly in that period of switching from just playing to more composing and creating, I discovered that you can actually see sound through this big thing here, and heavy thing. And I was really fascinated. So I don't want to give a lecture, or something very technical, unless you are very interested. But the plan for this workshop is more to keep it open and to have also hands-on, so you can actually try and see how it works. But if you are interested in the technical part, or at least in an introduction of it, I'm very glad to go quickly through it. And this is by the way, my research that is published online. If you look for a research catalog and then wave creatures, you can find it. And there is a lot of stuff that you can check out. But who wants to know something like more like an introduction before we move on? Yeah? Okay. You are nerds like me. You want to know how it works. Okay, so I skipped the historical reference from Pythagoras, but no, actually I don't skip it. So, who knows what's the role of Pythagoras in like music theory? Have you ever heard of Pythagoras? Okay, so yeah.
Like a tuning system.
Yeah. So he made a tuning system. You know how he made it?
By using math intervals to calculate pitches.
Yeah. So using math intervals, but there is even a better, like more simple, not better, way of saying it. That is just he took a string, like can be the string of a guitar, and then just plucked it, and it was producing a pitch. And then he tried to divide it by 2, so like putting the finger, for example, on top of it. So only half is vibrating, and then he found out that that's an octave. And then he found out that dividing by 2 by 2 by 2, he has all the octaves. And then he said, what if I divide by 3? And he got a fifth, and so on. Okay, so divided by 5 is a third. And then he started to make up this system of ratios, where every mathematical ratios, like 3 on 2, for example, is a fifth, follows the series of the natural harmonics. Who knows about the harmonics? What are the harmonics? Okay, yeah. You can, yeah.
Like the higher overtones?
Yeah.
The notes?
Yeah, so each note from, like for example, let's take the voice, for example. It has a fundamental pitch that is what we perceive as the note, actual note that we are singing. Like if I do like woo, everyone is hearing like the fundamental. But on top of it, there are a bunch of other notes that are exactly the note that Pythagoras found on the string by dividing with these mathematical ratios. And these harmonics are also how you said, were used also to create the major scale. Because if you go up with a series of harmonic, you have basically all the notes of the major scale. But if you are, this is kind of basic of music theory. So I think online you can find a lot of videos about it and a lot of stuff. So we go on, but just so you know that this started long time ago with realizing that the notes are following a very precise mathematical system. You know, they are not casual, but our ear is actually a very good machine in hearing the sound that has mathematical qualities, you know. And then we jump very far in time and we go to the around the 19th century where someone invented this device called the harmonograph. So harmonograph reminds you probably of harmony, but this thing actually doesn't make sound and it's not connected with sound. It's actually, if you can see here, it has some pendulums. It has two different systems, but it has two pendulums in this case. And then these pendulums are oscillating and moving a pen on the top of the table. And then there is a piece of paper, and it's basically drawing the line of the pendulum. So if there is a pendulum going like this, and then another pendulum going perpendicularly, imagine they're going in two different directions, and then they make very interesting shapes based on the number of times that they are oscillating, like the frequency basically. So what else is oscillating? What is better than an oscillator? So who of you is into electronic music, ever used a synth? Yeah, nice. So you know what is an oscillator, and basically the pendulum is oscillating the same way as a sine wave oscillator. Okay, so that's why it's interesting to know that this thing, you maybe start to see a connection between the movement and the creation of patterns and the sound, because both things are created by oscillations. Okay. And then there was this guy who actually, for the first time, put the two things together, and he understood that something vibrating can actually create these shapes. So he was called Lissajous, and these shapes are called by his name. And what he was doing, he was using these tuning forks that a lot of singers are using, for example, to get the pitch in the choir before. I mean, probably you've seen, it's very famous, tuning fork. And then he was attaching a little mirror on it, and then projecting. This is a very ancestor of a laser, but it's basically something that projects light in a very directional. And then the light is bouncing on these mirrors and then projecting. Then there is a lens, but it's not very important, and projecting. And when these tuning forks are vibrating, you start to see this kind of shapes. Okay, and this is very interesting. Like, why these kind of shapes? And then we jump again in the future, and we go to direct to the oscilloscope that you can see here. And what is the oscilloscope? It's a measurement, scientific, technical device that is showing on the screen a voltage. So it's being used for until now. It's being used. Now there are digital that are much smaller and lighter and easy to carry around, but it's being using exactly the same system to measure voltage. And what's interesting about the oscilloscope is that, so now I'm talking this microphone, and what is the microphone doing? It's converting the vibration of my voice into an electric signal that is going through the cable. So it's voltage. It's basically the vibration is going from negative to positive voltage, and then you can see this thing on the oscilloscope. So 2 plus 2 equals 4, it means that you can see my voice or any sound on the oscilloscope. I think we can actually give it already a try. Or maybe actually, let me first show you something else and then we go to the practical part. Yeah, maybe I want to just show you quickly. This guy is a genius and he made something.
Hey you guys, I want to show you something amazing. I'm running an audio signal through an oscilloscope. We can see exactly the same waves that we're hearing at the same time on both audio channels, and use them to draw those sounds.
Okay, here I stop. Yeah, I stop because he's going a bit too far, I think. No, what I mean is, first of all, you see these little like lines, like a grid. This means this video is actually a recording of an oscilloscope, analog oscilloscope. And that I find really cool, and aesthetically I really like it. But so at the beginning you saw actually his voice, okay? And that's also what I wanted to show you. And then you start to see a lot of cool, very cool stuff, but you're like, what? You know, like it's a cube? How can sound make a cube? And here it's like the difference from what I'm doing from what he's doing is like he's making 3D models and then he's using a software to transmit a signal that is making this shape on the oscilloscope. And then each shape can be created with a different frequency and a different pitch, so you can make music out of it, but it doesn't mean that what you see is the exact representation of the sound, because in a way it is, but in the other way it's an artificial. Yes?
Is a spectrogram like related to an oscilloscope? Because I remember FX drawing his own face in the song,
Yeah.
which was really baffling to me, so I thought like, is there any
Yeah.
relation to it?
I think there is a relationship, but it's more conceptually. That means you are using a tool that is able to visualize the sound to use it more visually than sonically, or at least to combine it. And that's also what I'm trying to do. But the spectrogram is showing very complex representation of the sound that is using very complex mathematical equations, specifically the Fourier transform. I don't know if everyone, but it's used in every plugin. You're using like an EQ, and then you see like the frequencies when you play, and you see the frequencies. That's made with the Fourier transform and the spectrogram, all this kind of stuff. Okay, so it has conceptually a connection, like the aim is the same, but the technique is completely different, because this is just taking the signal, the vibration, and showing it on the screen. And I'm gonna, because I guess it sounds really abstract for now, or at least like, how does it work actually? Like why you see those kind of shapes. So I want to show you first, let's do with the video so it's quicker. Yeah, this is just a sine wave. Yeah, wait. Let's see what I'm doing, and then remember. Yeah, I'm changing like some parameters on the oscilloscope, like the position and the zooming in or zooming out, but it's not very important. So now you're seeing the shape of the waveform. It's a sine wave, so very smooth and simple. But the thing is that it's really two-dimensional, no? Like you see, it's going up and down, up and down. So like on this, as you see here, on this axis you have time, and on this axis you have voltage. So it's going up and down, up and down, up and down, and then you just see it on the screen. But I don't find it so exciting as circle. Circle is more exciting. So wait, I don't want to spoil. I'm going to show you just a quick example from the line to the circle. And what's very interesting is that the circle starts to do something and it looks three-dimensional. So now I'm going to send two sine waves on the same oscilloscope, you see? So one is going a bit, they are slightly detuned. One is going a bit higher and one is going a bit slower. This is the sum of them, it's not very important. So you see they are oscillating between themselves, okay? Very slow frequency because they are almost the same frequency. But then there is a setting on the oscilloscope that instead of using, I'm going to pause for a second, instead of using voltage against time, it takes two signals from here and from here, and it basically sends one signal to one axis and one signal to the other axis. So you have time is not there anymore, at least time is just, you just see it in the moment because it's moving. So yeah, it's like going from the two-dimension to the third dimension, something like that, and that's how I think it starts to look three-dimensional even if it's not. And then I'm tweaking a bit other parameters, but what is interesting is when I'm going to change the frequency of one of the two oscillators. And as you see, it starts to make very interesting shapes. Do you recognize these shapes, like when it stops somewhere like this? It's a lissajou. So instead of using tuning forks, you are using signal voltage, but it's exactly the same thing. And these shapes are the same that in the 19th century, like very wealthy families were doing in their caterings with their monograph and with the pendulums of their monograph and drawing on paper. So exactly the same thing. Then here there is the mathematical, trigonometrical explanation why you go from a sine wave to a circle, and you can check it out because it's, I mean, visually, if you look it for a bit, it starts to make sense, but it's also, I think, not very intuitive. So if you look about projection of two sine waves online, you find this kind of stuff. And then, I mean, what I've done is just to create all the music intervals on the oscilloscope. Here we enter in another world that now there is no time, but we enter in the world of just intonation. Who knows just intonation? Okay. It's a really good one out of 20, I don't know. So just intonation is actually what Pythagoras was using with exact mathematical ratios, like 3/2, 5/4, this kind of stuff. They almost don't exist in reality, they can be made with the oscillators, but and also just intonation was used until Bach started to compose very complex music that was going from one tonality to another tonality, okay? So maybe he was starting in C major, but during the piece it goes to, I don't know, D flat major is the tonality next to it. It means that all the notes are different, and what happens? The just intonation of C major doesn't match the just intonation of D flat. Also this thing, if you're interested, you can check it at home. But what they did from that point on, they started to tune the instruments, especially the keyboard instruments, with the equal temperament. So like, I have vibraphone here, and equal temperament means that each semitone is exactly the same distance, okay? And the octave from C to C is divided in 12 semitones that are exactly the same. But in this way, you lose the just intonation between each individual interval, and you go in a more, let's say you find a compromise, so you can play in every key and change key or play pieces that are in different keys on the same instrument, losing the pure intonation. And nowadays our ear got so used to that the just intonation sounds out of tune, and that's crazy. But actually the music that we are making every day, listening every day with a piano or with any software, it's a equal temperament, and that means it's not actually really in tune. So these shapes are made when things are using just intonation. Am I going too technical? Should I move on, or you like this stuff? Yeah.
Just one question.
Please.
So, when Bach wrote his music, it was in just intonation played as well.
Yeah, there was. I mean, now I said it in a very simplicistic way, and like to make it simple. I mean, Bach was in the period where composers, he was like a pioneer of harmony, and was the period where composers start to modulate and go between tonalities in the same piece. Yeah, and he very famous is his well-tempered clavier. I don't know if you ever heard, and it's a series of pieces in all the tonalities, and that's one of the first famous examples where they switched. Still not equal temperament, but it's well tempered. Yeah. So it's something in the middle, and then later they figured out this thing of dividing exactly the octave but it's. I relate it to Bach because he's the one who initiated this thing of yeah.
I'm kind of interested if orchestras perform it in just intonation.
Yeah, and that's a very good question. In general, yes. Also because a lot of instruments that play in the orchestra, for example, I mean the piano is not always there, but when there is the piano, 100%. The harp, for example, cannot, like has strings that are tuned in a fixed way. The thing is that in some specific music that is played, for example, by brass instruments, they can actually, if they rehearse and they are trained to hear the just intonation, they can actually use just intonation. And I think in a full orchestra, there is a bit of both things, as soon as in general it works. But if there is, for example, a piano concerto, the piano is ruling everything, But depends on the specific piece. There are nowadays it's coming as a trend, and there are a lot of just intonation composers that write exactly for just intonation. Yeah. If you look for just intonation music, you can find on YouTube a lot of interesting explanations, but also examples of music.
Also probably in a 432.
Yeah, but that's not. It's following the same trend. Like they want to go back to 432 and just intonation, but the two things are completely unrelated. You can be in 432 equal temperament, or in 440 just intonation. Yeah. Right? Correct me if I'm wrong. Yeah.
I have a question, but
Yeah.
it's more related to the visual aspect, because when I look at those figurines behind you, they remind me of like the art style Celtic nuns. Do you know those?
No?
They're like in Ireland and in Scotland you have here.
Yeah.
It's like a geometrical shapes.
Do you want to just say it
From
in
the Neolithic age. If you can see, well, okay. You can look at them maybe, but it reminded me,
look them.
of it's called Celtic knots.
And it's because I came here also for the visual aspect. But do you want me to explain what I said?
Yeah.
Okay. Well, it's like an art style. You can find it in Ireland and Scotland, and it's very old. It's like the Neolithic period, and it's all geometric shapes placed in stone. So when I see your green figures, I see the patterns in here. So I wondered, does it work the other way around? So you can make sound into shape, but can you also, if you see something like this, well, not exactly this, but if you look like maybe this one, could you like find out the sound?
Yeah, it's a very interesting question.
Yeah.
Also because I'm happy that there is someone interested in the visual part, because here we are like more in the music realm. But in my project, I try to balance the two things. They have the same weight, you know. So to answer your question, you cannot transform any image into or any shape into sound. Actually, technically, you cannot transform an image into sound with this system, with the oscilloscope. Technically, what you can do is like study how it works. For example, here I explain how these shapes are made with the interval. So lateral is the type of technique of the harmonograph. I took the name from the harmonograph. And 4/3 is the mathematical ratio of a fourth. So you know that a fourth is creating this pattern. Now it's rotating because it's slightly detuned, but if you tune them exactly, precisely the just intonation fourth, then you have a stable thing. And the funny thing is that I'm gonna show here, like this is 5/4, a major third, and it has 1, 2, 3, 4, 5, and on this side it has 1, 2, 3, 4. So, for example, this one looks quite similar, and then it has 2 and 1, 2, 3, 4. So you know already that you can do something like that. With 3/2, there is a fifth.
But for example, that green square, if you see it, do you know what sound is behind it? Because you make it.
Yeah, so first of all is sine waves, because when you see these liveshow figures or this, there are sine waves. And second, so what you see is both the harmony, that is the interval between the two notes, but also the timbre of the instrument. So sine wave is the best to create these patterns because it's a perfect function. Yeah. I think you asked one more thing and I forgot, but no, it's okay. Yeah.
I was curious about like what was your like on the music aspect, the inspiration for this project, because I was at the showcase earlier upstairs.
Yeah.
And like at some points it reminded me of early Square Pusher. I don't know if you know him.
Again, can you?
Square Pusher.
I heard his name. Maybe I heard some stuff.
So is
Okay.
that like any electronic artist or whatever artist?
As an influence.
Yeah.
Okay. I mean, for this concert that you saw, the main influence was actually just the material from the archives. Like I was just playing the material and trying to feel where I could like chop the sample and then loop, or use the sample to harmonize or to start from there. But in general, I mean, I'm listening a lot to electronic music. I can name endless.
What's your favorite?
My favorite. It's so hard. I cannot say. I like Aphex Twins a lot. I like Flying Lotus. Yeah, so many. I also listen a lot of jazz and electronic music together. Like for example, Louis Cole. I really like his stuff. Yeah.
check out Square Pusher because it
Yeah.
reminded me of
But the name is very familiar. I think I have it somewhere on Spotify in the playlist. And, yeah.
You spoke about timbre affecting what you see on the oscilloscope. If you ran like a guitar or a xylophone,
Yeah.
you get different images.
Yeah, that's what I would really love to start to show now. Okay, so you got that there is a lot of mathematics behind, a lot of ratios and things like sacred geometry. You can really go into it, but this is how the instrument starts to look. That is very chaotic. I'm gonna just show tiny bit. This is a piano. Sorry. Like very chaotic. As also you saw in the samples that I used today, there was a lot of moments where
the
really.
saxophone was really simple.
The saxophone is amazing. I really love it how it sounds. Yeah, and it really sounds like it looks like the sound. You know, like I mean, most of the times it's like that. I shouldn't be surprised, but when you see the saxophone doing like doodle doodle boo doodle that kind of stuff, and then you see how it's moving, it's really really impressive. But this is an orchestra. I mean, it's like a bad Windows Media Player. Sorry, I need to show you. This is three-dimensional oscilloscope. So one note, two notes, and then just rotating a little bit. Triad. So this is a chord, 3 notes, and this is how it looks in 3D with slightly detuned, so it's rotating. Yeah, just wanted to show you because I think it's, sorry.
Does it matter which interval you detune to make it rotate?
No. When you have 3 notes, it matters in which direction is rotating. Like, it can rotate more like this or more like this, depending which note is detuned.
So it rotates with each interval?
If you, for example, when you have 3 notes, you can detune first one, and you see it's turning like this, maybe, and then you detune also another one, and maybe you see it's starting to move a bit in obliquous direction. Done a bunch of stuff. Let's go to the practical part also because time is running out. So first let's set up the oscilloscope, if it still works because I didn't turn it on for a long time. Okay, so you start to see the dot, it means it's working. And then this mic should be attached to the oscilloscope. No. Sa 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 sa. It's very soft. Sa 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 sa. Can you see something moving? I'm really sorry. This is called feedback. Nice to meet you, feedback.
It did move there.
Now, you see it moving, something? Then maybe, can we turn off from the mixer the audio interface? Sorry, I didn't plan this to happen. Yeah? Let's see if something is moving. Oh, nice, finally. I have to keep 2 mics. Okay, so right now it's just a line, and that's because This is very hard to explain, but when you have just one microphone and just one sound, basically it's going to the both axes the same value, and then it comes out a line that is perfectly obliquous. It's like x equal y in mathematics, okay? And then I can change the mode of the oscilloscope, and I can go, for example, to, where is it? XY? Yeah. Okay, so, yeah, this is the waveform of my voice, and it's shown in a linear way, okay? So time and voltage. And then if I put to XY, all of a sudden it becomes a line. So what I have to do now, I'm getting crazy with two mics. I will drop this one for now. What I have to do is actually to go through, in this case, my DAW, or even better, anyone knows Max MSP? This is more complicated, but if you know how to use it, it's actually more simple. So I just do an input. There is analog to digital. So this is gonna take the input from my mic. Let's see if it works. So one thing about Max is that whoever has Ableton suite, it has Max inside Ableton, okay? So now for simplicity and to be quicker, we go directly to Max, but you can do the same thing here by creating a Max for Live device. Okay. Let's see. Okay, so we have a signal. By the way, there is also a thing. Hey, I need two hands. There's a thing called scope also here. And actually, before using the analog one, you can check. This is very ugly and it's a bit not good, but just to. So now I need to go out from the audio interface. So maybe digital to analog. And now I think you should see something. Okay. Good. So we have two channels, as we said before, and one channel needs to go. Okay, so before you were seeing probably a line like vertical, and now you should see a line obliquous. Yeah. So what we have to do is to delay one of the two channels. Okay, and this you can do also in Ableton with a delay, but it should be very, very short delay. So for this we use the delay object. And then we set a delay time. And now we see the same thing because this is set up too. How's it now? Yeah. Okay, finally, sorry for the long wait. But yeah, with this you need to do like this because it's analog, so you need to find a way on the laptop to delay the channel and then you can see your voice. And actually, it's very interesting when you change like the vowels, or like so when you sing in falsetto, for example, with a U sound, you get basically a circle because it's very similar to a sine wave, no? Like, and also what's very interesting, and here I call my assistant, is that the vibraphone has a sound very similar to the sine wave as well. Vibraphone. Play another note, like yeah. Thank you. That's it. So who is a singer and who wants to try this thing out? Yeah? Sure.
Is it like the overtones the vibraphone gives?
Yeah, so when
It sounds like a sine wave after he hits the note.
Yeah. So another technical disclaimer: sine wave is a pure sound. It means it has no overtones. It has only the fundamental, and then it creates a circle in this case, or like that sine wave waveform. And the vibraphone, the decay of the vibraphone is almost a sine wave. Okay. Yeah. Other instruments, I have also my flugelhorn if you want, my trumpet if you want to see later. But let's try with the voice, okay? You can use both mics, or this is the one.
I'm not actually that much of a singer, but I'm just interested.
Yeah.
So now it's delayed, right? So if you say falsetto, and if I try singing it differently, would it change shape? So, yeah, that changes. Can we try like singing a major third or something?
Yeah, that's a good. Sorry.
Do you mind helping me, or can I just?
Yeah. Meanwhile, if you want to help, or any other singer wants to help, meanwhile I set up the thing in Ableton. Anyone?
You want to help? Okay, so I'm curious if we can make like one of the shapes if we like sing intervals or play intervals. I don't care.
No, you can sing. Maybe you can do the third. No, we should use the different mics, right?
Yeah. So if you sing one note and I sing the third, then we should sing. Because this one is not going.
This one's not going to.
Yeah, you need to use the same one. Yeah.
Oh, the same one. So you want to sing the first one?
Yeah, what's going on?
Try the intervals. We try changing shapes. So if I sing like, oh, that's the same thing. Did you change the delay time? No, you didn't. Does anyone have a clever idea we can try? You want to try the...
Yeah, together.
You want to start?
Okay.
So like, shall I just sing one note and you sing whatever you want on top of it? you try singing one note?
Yeah.
Then I'm going to try to sing the unison, and then I'm going to try to sing not in tune.
Okay.
False.
1 second, I have an idea. It's great. Try to sing like oo sound and a falsetto if you can. It's even better. So the harmony starts to make more difference and sense, because if the timbre of your voice is already complex, then you don't recognize anything about the harmony, right? So if you are trying to make a pure sound, then you can see the interval at the end. Yeah. Good luck.
Hoger?
Zo hoog kan ik niet.
Oh, dat was mooi. Wow.
For example, maybe try again and try to change to gliss between the notes, okay? Like ooh. So when you go up or down, the circle is rotating. That's one of the features.
Yeah. You can see it. You can see it if you start getting more like grit in your voice, then it starts to wobble more.
Yeah. Also another feedback. Another interesting thing is no, I forgot. Sorry. What did I want to say? Because you did something and I thought left. Okay, if it comes back, I'm gonna say it again. But I want to continue very quickly. So this is Ableton, and I think most of you knows more or less, or Ableton or any DAW in general. So this is the device that I'm using, and I made it on Max. So this is you know the whole thing. If you're interested, I can give it to you. Maybe send me an email or something. You can find if you Google my name, you can find my website and then my email and everything. I'm willing to share it. So you see here is made in a more simple way. So what is called the phase is actually the delay. So if it's 0 or close to 0, you have more like a line, and when it opens up, you
So it's basically just a VST you can just put on.
It's not a VST actually. It's a Max for Live device that it works only on Ableton.
Only on Ableton.
Yeah. Yeah. Maybe in the future I will try to make a VST, but yeah. Yeah, and then you can change, of course, like visual things like how thick is the line, or the color. Yeah, this kind of stuff, and like how much it glows, for example.
How does it respond to drums?
Drums is very interesting, and it's also another kind of another subject, because drums don't have a pitch usually. So you see, also usually it has like very strong attack, and then nothing much left. Even the ride or the cymbal like is very strong the attack, and then very soft the rest. So for the percussive sounds, I usually since we are in the digital domain and we can do whatever we want with these lines. Instead of drawing a line, I'm drawing dots that are staying there for a bit. And you saw a bit, if you were in the concert, you saw a bit in some parts. There was like this kind of looks like galaxy or stars in some samples. Yeah, white and violet stuff that was maybe there and then fading out. So the nice thing is that once you understand the system, you can use then like your ideas to change also how you visualize it. Okay, can be a line, can be points, can do so many different things. Yes. Other questions or yeah?
Does it react different to stereo signals?
Yeah, that's very interesting. So the simple way is to turn the signal to mono and then delay one of the two channels. With stereo signals, really depends. Like, can be problematic because you cannot control. So there is in the recordings, for example, there is a reverb, or so you see a 3D shape, but it's not really representing the sound itself. It's more representing this reverb, and the reverb is noisy because it's something that is staying there for a long time. What is really interesting with stereo is to have, for example, two instruments completely separate. For example, if you are on your DAW, you can do one channel, one instrument isolated, and the other channel, the other instrument isolated. And then you can actually create panned. Yeah, one completely right and one completely left. And then you can actually create those lissajou figures. Okay. Another thing that I can show you is, so let me change 1 second the setup. So instead of reverb, I'm gonna put the oscilloscope in a bass channel, and then here I have can we have again the sound from the audio interface? Nothing? Should hear sine wave? Wait. Playback. Yes. Hey. Is it also here something? Small. Okay, so I can put it bigger so we can see both in the analog and in the digital one. Is it okay now? Too big, or it's fine? So now if I send the oscilloscope, and then I change a bit the parameters, like a bit of delay. This, I don't tell you what is it for now, it's not necessary. Ooh, it's huge. Okay. So here you can start to see the harmony. Actually, I'm a bit messy, but I even brought a Rolly keyboard. I don't know if you know what is it, but it's a keyboard that you can. It doesn't have keys. It has like soft touch thing, and then you can play the notes and then change the intonation, and you can find the just intonation. But maybe for another time. But what is interesting to show before we wrap it up is less bloom amount. Yeah. If anyone wants to come and try to play with the keyboard of the laptop. Like, or I can just show you, like, for example, this is a fifth. Looks really nice. There's a bit, I think it's a bit too loud. So this is a triangle wave. Oh, sorry, this is sawtooth. This is square wave. Yeah. And then if I change a bit the delay, I can change the perspective from where I see the interval. This triton is very aggressive. Major third is also, because this is equal temperament, so the major third in the equal temperament is really not close to the pure one, to the just one. Yeah, I mean, it was a lot of stuff in 1 hour, and I think you are very confused. You might be very confused even more than before, but I think it was a nice inspiration, and you are always welcome to reach me out if you have other questions, or you want the device to put on your Ableton, or you have an idea, you want to see if it's possible, you want to collaborate, whatever, you know, like please reach me out. I can show you my email, maybe. I mean, this is my website, and then there is also my email. You just go, it doesn't load perfect. Just go here and you can contact me from there. Yeah, I hope I gave you a different view on how you hear the sound and music, and to know that it's a very limited perspective, because sound is like much more than just what we can hear. So I hope you will bring something home from this. Have fun.